Hi, my name is Emmanuel Kalusi. I am a technical consultant at Hewlett-Packard Enterprise based at Customer Innovation Center in Geneva. The purpose for this videos is to show you cloning a database and using this clone in a second SQL Server workload into a Kubernetes cluster. Using CSI Driver technology for persistent volume. This video is the continuation of the video published last month, in October 2019, with the deployment of a single SQL Server instance using the CSI Driver technology. If you have not seen this video, I invite you to watch it to understand the CSI Driver technology and how HPE implements it. I do not detail the configuration used, it's the same as the previous video. Over the last few months I have done a lot of work and research in the area of Docker containers and Kubernetes. Therefore, I want to show you in today's video posting how you can achieve and how HPE with its technology can help you. Let's get started. Just to backtrack, in the previous video posting I have talked about the various advantages running a single instance of SQL Server in a Kubernetes cluster. One of the advantages is that Kubernetes always makes sure through the replica set that the requested amount of pods are always online, healthy, and available. In our case we have requested in the replica set 1 pod, therefore 1 pod will be always available. Let's try that, and delete our one and only pod that is currently running SQL. You can see that Kubernetes itself has triggered the creation of a new pod. And after some time that pod will be again in the running state. The great thing about that is now that the persistent volume of the old pod was attached to new pod, and therefore we haven't lost any data. If you have previously created a new SQL Server database, that database will be still accessible with the new pod. You can also see with the following command that the persistent volume was reattached to our pod. Okay, we will now remove our SQL Server pod deployment, services and persistent volume. The volume is automatically deleted on the Nimble storage. So, let us start our new configuration. Let us start by creating our persistent volume and then deploy our SQL Server instance. The persistent volume is created. Now let us deploy our first SQL Server instance. Our first SQL Server instance is deployed. For convenience I use the node port service instead load balancer. Doing this exposes the service which is running on 1433 inside the pod and also on the pod network to the node's real IP address, and bind the pod's internal 1433 port to an available ephemeral port on the node. Now we will restore our database. From the previous step, we created a database. We now want to clone it into a new persistent volume claim and use in a second workload. Let us pretend we want to debug an issue that is potentially disruptive to the production database. We create a new persistent volume claim with an annotation that instructs the dynamic provisioner to clone from the previously created persistent volume claim. This is what the clone persistent volume claim looks like. Let's create the persistent volume claim. The persistent volume claim is created. Now, create another pod that references the new persistent volume claim. The pod is created and running. Let us look at the ports used to connect to our SQL Server instances. Let us inspect the clone database. You should now see your data cloned from the previous steps. The database is now ethically cloned and whatever you do to it won't affect the original. Okay, you just saw how easy it is to use HPE CSI Driver for Kubernetes, to provision storage, duplicate environments in a container context. Currently this is just a beta. We expect to hit GA later in the fall. More platforms, protocols, and services should follow shortly. The final version will also include all the latest capabilities in the CSI specification. We will also be able to demonstrate the capability of doing online resize of any of the supported file systems. Thanks for watching.